So Coulomb's law is really the principle for matter existing the way that it does. Here's Coulomb's law as an equation. The force, the electrostatic force, is equal to a constant times the magnitude of one charge times the magnitude of the other charge divided by the distance squared. And this equation gives the electric force between 2-point charges. It's another inverse square law, just like the acceleration for the force due to gravity. So you have the same algebraic relationships between the two. Another example of an inverse square law is the energy of an electron, Bohr's equation from the first video. Okay, so breaking down the equation a little bit more, K is a constant, and it's Coulomb's electrostatic constant, 9 times 10 to the 9th Newton meters squared divided by Coulomb squared, and that's just derived from the variables that remain in the equation. Like we said, Q1 is the charge on mass 1, and Q2 is the charge on mass 2, and R is the distance between the two. What Coulomb's law, the relationship the relationship between the variables say, is that there's two major takeaways. The bigger charges mean stronger bonds, while smaller charges mean weaker bonds. That's the first major takeaway. And the second is that charges close together mean stronger bonds, while charges farther apart mean weaker bonds. So this is really what the algebra is saying. Force is inversely proportional to r squared. So a lot of times the way that you're going to see that tested is they will change the distance and then ask for the effect on the force. For instance, they'll say if the radius between two charges is doubled, then what will happen to the force? And since you know that force is inversely proportional to r squared, you can say that doubling r would be inversely proportional to what happens to f, so 2 squared would be 4, and therefore since r would be increasing, then f would have to be decreasing by a factor of 4. Let's look at the same relationship between force and charge, and since both of these variables are in the numerator on opposite sides of the equal sign, then they have a directly proportional relationship. So whatever happens to one happens to the other. If you double the charge, you double the force. But since in the previous example, since r is in the denominator, that is the inverse of what's happening to f, and you see that it happens by r squared. So Coulomb's law is really the principle for matter existing the way that it does.
Created using Powtoon.